Okay, the purpose of this video is to help you get prepared for your test coming up on Friday of this week. And so I'm going to go over first the formulas, and then I'm going to go over the answers to your review sheet with the 10 questions on it in class so that you can get an idea of what those answers are like. Hopefully this video will help you get ready so that our first test is a good one. Let me just review the formulas that we're using on this test first. Two main topics that we talked about in class. The first one was arithmetic formulas, arithmetic sequences and series. And what I want to do first is talk about the different types of formulas that you will need to know for this test. And the first one is a recursive formula. Remember, a recursive formula is based on the previous term. So to find any term in an arithmetic series or sequence, you're going to start with a sub n. You're going to take the previous term, which is a sub n minus 1, and you're going to add the common difference. If we're talking about a geometric sequence, and we want to write a recursive formula for it, we're going to find each term by taking the previous term, so a sub n equals a sub n minus 1, and we're multiplying by the common ratio. Because arithmetic sequences are repeated addition and geometric sequences are repeated multiplication. Another formula that you will need to know are what the explicit formulas are for these two types of sequences. An explicit formula is based on the term number instead of the previous term. So to find a sub n, we're going to start with the first term, a sub 1. We're going to add the common difference, n minus 1, number of times. However, in a geometric sequence, to find each term, we're going to start with the first term, a sub 1, and we're going to multiply times the common ratio, n minus 1, number of times. We also talked about means. There are two types of means that we talked about, averages that we talked about, arithmetic and geometric. To find the arithmetic average, that's the one that you guys have been doing for a long time. You take the two terms, add them together, divide by 2. Geometric, you take the two terms, you multiply them together, and take the square root. Both find a number in the middle, and both are used in different ways in math. So the other thing we talked about was a series. These are all types of formulas that we're going to need for sequences, but then we talked about a series, and within a series, remember, a series is when you add up all the terms in a sequence. So we're going to find the sum of all the terms in an arithmetic sequence using a formula that looks like this. We did this in class with the numbers 1 through 100. To find the sum of all the terms in an arithmetic series, we take the number of terms divided by 2. We take the first term plus the last term. And this only works for finite arithmetic series. If it's an infinite one, we cannot find the sum. Geometric series are a little bit more complicated because we can find a finite one using this formula that we developed in class, a sub 1 times 1 minus r to the nth over 1 minus r, where r is the ratio, the common ratio, and n is the number of terms, and a sub 1 is the first term. This works if it's a finite one. Remember, finite geometric series can diverge or converge. It doesn't matter. We can find the sum either way. However, if it does converge, which means the ratio is less than 1, then we can find the sum of those numbers, even if there are an infinite number of numbers. And we do that by taking the first term over 1 minus r. As this approaches infinity, as the number of terms approaches infinity, then this, everything in parentheses, would approach 1, which means the formula would just be the a sub 1 over the 1 minus r. The other thing that we talked about in class that you should be familiar with is summation notation, which looks like this. We have the lower limit, so like n might equal, let's go from 5 to, let's say, 25. So in this case, there would be exactly 21 terms, starting with the 5th term and going to the 25th term. Then we always have some type of an explicit formula. It could be arithmetic or it could be geometric, depending on what the series looks like. But it might look something like this, where we start with 14, and we add a common difference. Let's say it's 3, n minus 1 number of times. And you should be able to translate from summation notation to just writing out the different terms in class. That's a review of all of the formulas that we need to know. But let's take a look now at the assignment that we had today, and we're going to quickly go over what the answers are. And then if you want to look at any of these answers to make sure that you got them correct, we can go ahead and do that. So we'll just go over each problem one at a time, and you can take a look and see if you got the same thing. Number one, write this series in summation notation. So in summation notation, this series is going to look like this. We have the sigma. We're going to start with the first term, so n equals 1, and we're going to go from 1 to the 18th term, and then we want an explicit formula here. So our explicit formula is going to start with 33, and we're going to add 4 n minus 1 number of times. So this is what you should have for number 1. It is an arithmetic because we're adding 4 each time. And so that's why we have an arithmetic explicit formula. We go on to number 2, evaluate this series. Again, it's arithmetic. We're adding 3 each time. And so now we're going to use this formula. We're going to take the number of terms divided by 2, and then we're going to take the first term plus the last term. One thing we don't know here is what the number of terms are. And so we're going to have to write an explicit formula to figure out what the 121 is as far as its term number. And that's going to look like this. We're going to take 10 plus 3, n minus 1 number of times. And we're going to set that equal to 121 and solve that equation for n. That ends up being 38. So we would take 38 divided by 2 times 10 plus 121, which ends up being 2,489. Let's move on to number 3. Consider the following equation. First of all, we know that it's an explicit formula because it doesn't have anything to do with the previous term. There isn't an a sub n minus 1. It's in terms of the term number, which is what n is. So this is an explicit formula. And is the sequence arithmetic or geometric? Well, if we distribute that, it's 3n plus 6. That's like a linear equation. We would start with like 6. We'd be adding 3 n number of times. And that's one form of a type of arithmetic sequence. Let's move on to number 4. Write an explicit formula for this. So we have 8, 6, and then 4.5. It looks like at first we're subtracting 2, but then the 4.5 we're only subtracting 1.5. So maybe we're multiplying by something. If I try to figure out 8 times something to give me 6, I can divide by 8, and that's 0.75. So 8 times 0.75 gives me 6. 6 times 0.75 does give me 4.5. So this is a geometric sequence, which means we're going to have something that looks like this. We're going to start with the first term, which is 8. We're going to multiply by the common ratio, which is 0.75, to the n minus 1 power. And then it says find the 40th term. So we're going to plug 40 in for n. And actually we're going to take 8 times 0.75 then to the 40 minus 1 power, or to the 39th power. And probably need a calculator for this one. It's 0.00010,727 would be the 40th term. We move on to number 5. Find the missing term of this geometric sequence. Since it's geometric, we're going to multiply them together. We're going to take 15.5 times 95.5 and take the square root. And when we do that, we get 38.474. Again, I'm going through this kind of quickly. If you have questions, you can ask me in class about it, or you can rewind and maybe watch this again. Number 6, we're going to evaluate this series. We're going to go from the first term through the 13th term. The first term, if I plug in a 1, 1 plus 4 is 5. And if I plug in a 2, 2 plus 4 is 6. Then I would get 7 all the way to when I plug in 13, 13 plus 4 is 17. So this is an arithmetic series. because I'm adding 1 each time. And so I'm going to take the number of terms, which is 13, over 2. I'm going to take the first term plus the last term. That's 6.5 times 22, which is 143. Let's move on to number 7. Evaluate the following series. We go from 32 to 24 to 18 to 13.5. We're not adding the same thing each time. Looks like we're subtracting 8, then we're subtracting 6, and then we're subtracting 4.5. So it's not arithmetic. But it might be geometric if we can figure out what we multiply each term by to get the next term. And so if I take 38, or if I take 32 times a number to get 24, I can divide both sides by 32, and I believe that is 0.75, like it was earlier. So I think if I multiply 32 times 0.75, I get 24. 24 times 0.75 gives me 18. 18 times 0.75 does give me 13.5. So this is a geometric series. To evaluate it, we're going to add up all those terms, which means our formula is going to be S sub n equals the first term, which is 32, times 1 minus the ratio, which is 0.75, to the nth power. So we have to figure out what, and this is over 1 minus 0.75. We need to figure out how many terms there are. Actually, the dots continue, which means it goes on indefinitely, which means I really wouldn't need this part of the equation. I would just use the formula that's a sub 1 over 1 minus r. So I'm going to take 32 over 1 minus 0.75, which is 128. Then it says to put it in summation notation form. So if I put this in summation notation form, I'm going to start with the first term, and I'm going to go through the infinite term. Or infinitieth term. And this is going to be an explicit formula here. And in this case, the explicit formula is going to start with 32. I'm going to multiply by 0.75 n minus 1 number of times. So that's what the explicit formula would look like in summation notation. Let's turn it over and look at the back. I know you may not be able to read this, but you have your paper. Hopefully you can follow along with this. Number 8, the smallest of 12 concentric circles. So we have a circle here, then we have a bigger circle, then we have a bigger circle. But the smallest one has a circumference of 11 inches. Each of the larger circles has a circumference that is twice as big as the prior circle. So the next one's going to be 22, and then 44, and then 88. And it's just going to keep going until we get to the 12th circle. So here we have the first term, the second term, the third term, the fourth term, and so on, until we get to the 12th term, and we want to find the sum of all of those terms. So here we're going to use this formula where we start with the 11th term. A sub 1 is 11. We're going to multiply that times 1 minus the ratio, which is 2, because we're multiplying by 2 each time to get from one term to the next, to the 12th power, because there are 12 terms, over 1 minus 2. If we plug all that into our calculator, we should get that that is 45,045. Number 9, we're going to write an explicit formula for this sequence. Starts with 22 and then 26 and then 30 and 34. Looks like we're adding 4 each time. So this is arithmetic. So the explicit formula would be a sub n equals the first term, which is 22. We're going to add 4, n minus 1 number of times. And then it says to find out what term will be 142. So eventually in this pattern we will get to 142, and we need to know what term that is. So we're going to set this explicit equation equal to 142. So we'll have 142 equals 22 plus 4 times n minus 1. We can subtract 22 from both sides. We can distribute the 4. There's a number of ways we can solve that equation, but regardless of how we do it, we should get that n is 31. The 31st term of this sequence will be 142. And then number 10. Number 10 is probably the hardest question on this review part. And let me just give you an idea of what this question is asking. A bird flew 12 feet on its first flight away from its nest, and then it flew back 12 feet. And then the next flight, it flew 30% more than 12 feet. So in other words, we would take 12 feet times 1.3. And then it flew back. And then it kept doing that. It kept getting 30% further and back, and 30% further and back. And so what we're going to need to do, there's really two sums here that we're going to look at, because eventually this will fly away the 12th time, and then but not come back. So it'll stay away the 12th time. So what I'm going to do first is look at its distance when it flew away from its nest. And we're going to take the sum of these 12 terms. And so we're going to take the sum of those 12 terms. We're going to start with the first term, which is 12. Then we're going to take 1 minus the ratio, which is 1.3, because it's 30% further, to the 12th power, because there's 12 times it flew away from its nest, over 1 minus 1.3. And if we plug that into your calculator, that's 891.923 feet. But then it also came back to the nest. It came back the first time, the second time, the third time, but it did not come back the 12th time. So this one is only going to have 11 terms in it. The first term is still 12. It's going to be 1 minus 1.3 still, but only 11 times over 1 minus 1.3. And if we evaluate that, that's going to be 676 feet, 0.864. And if we add those two numbers together, the distance it flew going away from its nest and its distance it flew coming back to the nest, it is a total of 1,568.787 feet. Hopefully you got all these answers correct, but if you didn't, you can rewind this video and watch it as many times as you want. You can also go to the part where we were reviewing and watch part of the review session of the video.